Hello and welcome to our physical sciences session. My name is Temba. Today we are looking at introduction to a very special type of reaction that are, very important in our chemistry, which are the redox reactions, right? We shall try and look at, what happens, when simple substances, in reactions, they form new substances, and then we try and check exactly what happens in terms of, the electron at an atomic level, in terms of electrons, in a typical redox reaction, right? Okay, so our focus for today is on oxidation numbers, okay? That's our main idea, which will form, the greater component of our discussion, right? But this is in the context of redox reactions, right? Okay, so the thought that's going to guide us today, or something that we need to think about as we go through our session or discussion, is that what exactly happens when oxygen reacts with other element. Take note, this is in the context of reactions. What happens when oxygen, not just to oxygen, when different elements react with oxygen, what exactly happens? So that's the big question that we want to put out there, right? Okay, some of the terminology or the key terms that we will make use of for the purpose of our discussion today, the following phrases, electron rich or electron poor. So it is about the electrons, right? Then the other key term is oxidation number. Okay, we'll try and understand what oxidation number is all about, and we'll try to make practical examples in terms of how exactly you go about in determining, or assigning oxidation numbers to different elements within a compound or, a polyatomic ion. And then we also look at electron transfer. So if we talk about transfer, exactly, it means there must be one thing that loses while the other one gains to facilitate that transfer from one, species to the other, right? So these are some of the key terms. Okay, now in the background, what is it that we understand? We know that during chemical bonding, atoms of elements have different arrangement of electrons, right? This actually goes back to, the basics, the fundamentals of chemistry in as far as the periodic table, to say when we talk about electron configuration, we're simply saying that it is specific to a type of element, because an element, is a substance that is made up of a particular type of atom, okay? So same atoms, they make up an element, but once these atoms combine with each other during chemical bonding, we can form, other molecules of elements or molecules of compounds or formula units. It takes us way back to chemical bonding. So that knowledge that we have, we need now to bring it forward and try and see how it fits into the bigger picture in as far as oxidation numbers are concerned. Right. So we are saying that when atoms join together, this is during bonding, okay, to form molecules or a network structure, right? So molecules will be via your covalent bonding, and then network structures, or crystal lattices were your ionic substances. Electrons are actually transferred or shared. So this is very, very important. The transfer of electron in the formation of formula units during chemical bonding is what ionic bonding is all about. But then the word core means sharing. So if we talk about covalent bonding, it essentially has to do with the sharing of electrons that occur at the highest energy level, the valence electrons between atoms. But why do these atoms bond with each other? I think we'd remember very well that this has a lot to do with actually, the stability, because they need an electron configuration that resembles that of group 8 elements, which are noble or stable gases. So that's the big idea. So we want to try and develop an understanding of oxidation number based on what we already know. Hence, it's very important for us to remind ourselves of chemical bonding, right? Okay, and then atoms that donate electrons are electron rich. Okay, so those that donate electrons are electron rich. It means they've got a lot of electrons, right? And then those that actually take electrons are electron poor. So for rich or for poor, but in the context of transfer, in the context of losing and gaining, this has to do with electrons. We're not talking about protons at this point in time, because we know in terms of, the atomic structure, the basic unit of an element, the atomic structure, we know that electrons actually occupy the energy levels, or the shells, which would alternatively refer to as the orbitals, okay? So hence we talk about loss or gain of electrons. It's very, very important for us to remind ourselves of that, okay? And then oxidation number, which is our key focus for today. What is it all about? So when we talk about oxidation number, the oxidation number of an element, this is for an element, okay, is a number assigned to keep track of electrons during a chemical reaction. Now, in the context of chemical reaction, there is loss, there is gain of electrons. Oxidation number of an element in a compound is actually the measure of the richness or deficiency. So richness, it means electrons have been gained. Deficiency, electrons have been lost, okay? So that's the understanding. And then oxidation number can either be positive or negative, right? What do we mean by that? We're saying that a negative oxidation number indicates that electrons were pulled towards an atom in a compound, okay? And then while a positive oxidation number tells us that electrons were pulled away from an atom, right? Okay, so in a compound or an element, there are two types of oxidation numbers. We've got a unit oxidation number, okay, which has to do with an element, and the total oxidation number, which can have to do with which has to do with a compound, or it has to relate to an element, where it has got more than one. But hence, focus is on total and unit, right? Okay, so if we talk about the unit oxidation number, it is written above the symbol of an element of a compound. Now, if for argument's sake we look at the unit oxidation number of sodium, sodium is in group 1, so its unit oxidation number is +1. But because in this compound of sodium oxide, what is happening, there are 2 sodium atoms, then the total oxidation number for this element is +2. Okay, hope it makes sense. And then the unit oxidation number represents the oxidation number of one atom of the element, in this case, which is +1. But what about the total oxidation number? Total oxidation number actually represents the number of, the total, of an element in a compound. Why do we have this +2 as the total oxidation number? Because there is 2 times +1, which is the oxidation number, which gives us the +2. So this +2 is actually our total oxidation number for sodium, right, in this compound, right? And then how do we assign? Oxidation numbers are similar to the valence electrons, and these valence electrons actually the number of electrons that occur at the highest energy levels. So there are a list of rules that will actually help us to assign oxidation numbers to elements. So what's going to guide us in this case are the rules, which is what is something that will focus our attention on. Right. So having said that, what's the main idea that we take in this segment is that, we talk of electron richness and electron deficiency. And then also that has to do with, the unit oxidation number of an element, or an atom of an element within a compound, as well as the total. But then after break, what we'll do, we'll try and make practical examples to try and understand the difference or the link between, unit oxidation number and total oxidation number, in as far as applying these rules of assigning oxidation numbers to elements. Let's take a short break for now.